So on this one, does it seem like it doesn't give you enough information? But it does. A rock falls off a cliff. The only place we're measuring how fast and how long it takes rocks to fall off cliffs is Earth. And on your formula sheet, you will find this. That is the acceleration due to gravity on Earth. That's the number you're going to want to know. Okay? I don't mean you have to memorize it. It's obviously on your formula sheet. But we use it all the time. Okay? Anytime an object is falling, even if you throw it up in the air, it's technically still falling. Okay? The acceleration due to gravity is 9.81 meters per second squared down. Okay? Everybody with me there? That's what that question, that's the whole purpose I put that question up there, is for people to understand, ooh, something's falling, okay, or something's in the air. It's in the air, okay, and it's not like in powered flight, then A is 9.81 meters per second squared down. Okay, that is just acceleration due to gravity on Earth. All right, so for this one here, now that we know that, okay, if it falls off of a cliff, how fast was it going initially?
0.
Right. Okay, if something falls or is dropped or something like that, then VI is 0. Just another thing we need to watch out for. If it's thrown, that's different. Okay, if it's thrown, then it's going to have an initial velocity. But if it's just dropped or it just falls off, it wasn't moving initially. Okay, so VI is 0. So there's a couple of tricks in this one, and they're contextual tricks. Okay, we have to know that within the context of this question, the object was not initially moving, and gravity is what's causing it to accelerate.
Is the final velocity like negative because it's falling?
In this case, because it only moves down, I can make down positive. Okay, because this is down. Okay, that is down, so down can be positive. They only have to make them negative if they change directions. Right. So if this was 42 meters per second up, then that would have to be negative. Okay, so I've got VI, okay, I've got VF, 42 meters per second, down. It never says that in the question explicitly, but it is implied because that's generally the direction things go when you drop them. Okay? Now it says speed there, but obviously if something is falling, it's also down. Okay, how long did it fall for? So I'm looking for time, and I have acceleration at 9.81 meters per second squared, also down. Okay, and as I usually do, I'm going to make up. Okay, that way I'm going to make down that way. Usually I make up positive, but in this case I don't have any ups, so I'm just going to go with that because it's easier. Okay, I can make them both negative; it'll come out the same answer. All right. So A equals VF minus VI over T. If I want to solve for T, multiply both sides by T, divide both sides by A. There's my new formula. 42 minus 0 divided by 9.81. I could also go negative 42 divided by negative 9.81. I'll get the same answer. Okay. What if I got a negative value for time? I shouldn't. Yeah, because by falling, I somehow went back in time. Yeah, because time can't be negative, or you're going backwards in time. Or falling up. Yes, that would be also impossible. I've never seen anyone fall up the stairs. Okay, I've seen them fall on them, but never fall and then magically move up the stairs. Nobody falls up. Okay, fall down. Okay, all right. So when we punch all those in, okay, to our calculator here, which I forgot to fire up. Where? Here? Yeah. That's a 9. That's actually A. Right there. That's 9.81. I was bringing the A over. My A's have long tails. Yeah, because my penmanship is terrible. I told my grade 6 teacher when she told me my penmanship was terrible, I said, it's fine. In the future, we'll all be using computers and my handwriting won't matter. I was both right and wrong. Because now computers are things you draw on. Partly right. I mean, who knew tablets were going to be things other than what you carve commandments into? All right, so 42 minus 0, obviously, okay, divided by 9.81. All right, so it's going to fall for 4.28 seconds. Okay? All right, questions on that one?
On a question like this, you would always divide by 9.81.
Well, because I manipulated it to be that way, yes. I wouldn't always divide by 9.81. There's situations where I could be multiplying by it, right? Like if I was looking for final velocity, I would have initial plus time times 9.81. It all depends on how you manipulate it. Yeah. Okay. Let's try that one. Okay, looking for our initial velocity there. All right, so on this one here, it says the race car reaches a velocity of 80 meters per second after accelerating. So that 80 meters per second, VI or VF? VF, and it becomes obviously clearer when later in the question it asks, what's VI? Okay, so obviously that can't be VI. All right, it's important to read the question to get those kinds of clues. Okay, 80 meters per second, since it doesn't tell me otherwise, I'm going to assume that's positive. Okay, and then for acceleration, it tells me also positive, okay, 4.5 meters per second squared. It doesn't tell me that, but I'm going to assume that, okay, and it does that for 12 seconds, right? We're looking for the initial velocity. All right, so A equals VF minus VI over T. This is the trickiest manipulation. Okay, so I've got to bring T over here, right? So I'm going to multiply both sides by T so that it comes to the other side. And then the way I do it is I add VI over to the other side. And then I subtract T times A together to come over here. That's going to solve for VI. Okay, so then I can plug in my numbers. Right, so that'll be 80, positive 80, minus 12 seconds times 4.5. Okay, so 80 divided by, or sorry, not divided by, 80 minus 12 times 4.5. All right, so that car, when it started accelerating, was moving at positive 26 meters per second. I would also accept forwards, because a race car is certainly not going 80 meters per second in reverse. Okay, to get context kind of clues, okay, for a question like that. Okay, questions on how that one worked? Anybody need that? Okay. All right. Direction matters here. Okay, we did one or two like this yesterday. Make note of up the hill, down the hill. Makes a difference here. Okay, I'll give you a few minutes on that one. Okay, so I heard people talking here while they were working on this one, and what I heard is good. It's exactly the kind of talk I want you to have, okay, in your head, obviously, if you're sitting on a test, not with somebody else. Okay, but it's exactly the things I want to hear you saying to yourself. I think the acceleration should be negative here. Okay? Yes, it absolutely should. This car runs out of gas while moving uphill. Unless it was right at the top, what's it going to do? It's going to roll back down the hill when it runs out of gas and can't propel itself forwards anymore. That means it's going to accelerate down the hill because of gravity. That means you're interpreting the context of the question. That's the hard part. Okay? The math of this one is really easy because you don't even have to manipulate the equation. You're solving for A. Okay, but the context is tricky, okay, and that's what we have to be aware of. So we're looking for the acceleration, okay. It says it runs out of gas while moving up the hill at 6.5 meters per second. All right, so right away, I'm going to draw a hill. I'm going to say up the hill is positive and down the hill is negative, and I'm going to write that VI is positive 6.5 meters per second. Okay, it rolls for 8.52 seconds. Okay, and its final velocity is 3.78 meters per second down the hill. Negative 3.78 meters per second. Okay, important that I put those vectors in. Now, as we said for this one, the math is actually quite a bit easier. At least the algebra is, because you don't have to do any manipulating of the equation. Okay, we just have to plug in our numbers. Okay, this is the tricky part. VF has to be negative because it's down the hill. So negative 3.78 minus 6.5, okay, positive, and then divide that by 8.52 seconds. All right, so I'm going to have meters per second divided by seconds. That's going to give me meters per second squared. All right, so negative 3.78 minus 6.5. Okay, hit the equal sign, then divide that by 8.52. All right, so the acceleration of the car is 1.21 meters per second squared down the hill. Okay, now, here's something that's going to seem super picky, and it's really going to matter when you get to physics 20 and 30. Are down and downhill the same direction? No. Down is straight down. Downhill is at an angle, not straight down. Okay? I know that seems incredibly picky, and it is, and I apologize for it not. Okay? Those are different directions. Down is vertically downward. You never fall through a hill. Okay? If you say the acceleration is 1.21 meters per second squared down, it means you dug a hole and somehow fell in it. Okay? Because you're falling through the hill somehow. Everybody follow me there? I know that seems super picky, and it is. Okay, that one makes sense? So the whole point of that one was not algebra. The whole point of that one was vectors. Okay, making sure that we put the proper signage on there, we keep track of uphill, downhill, okay, assign the right things, and then at the end, I don't write negative 1.21, I write 1.21 meters per second squared downhill. Okay, I have to go back to the vectors that the question gave me. All right. You know what, guys? I think we will leave it there for today. Now, hold on. Before you pack up, I need you to listen. Okay? For tomorrow's acceleration quiz, here's what we're going to do. We're just going to do it as practice questions. Okay? I don't feel like we're quite ready to be assessed on that, so I think what we'll do here is this. We're not going to have a quiz dedicated solely to acceleration. We will just do the problems tomorrow, and then we'll go through them as a class. Next week, we will be covering work and energy. Friday's quiz will have some acceleration and some work energy on it. It'll combine the two. Okay, does that sound fair? All right. Remember also that I'm talking about tomorrow like it's a school day. Because it is. Yes. I had this thing going on in my period 2 class. We're like, well, we're not going to be here on Friday. I'm like, why the hell not? Okay? The holiday is Monday. Okay? A long weekend consists of 3 days. That would be Saturday, Sunday, and Monday. You are to be here tomorrow. Okay? Tomorrow is a school day. I don't care what the other school division does. They can do their own thing. Okay? Here, we go to school on Friday before the May long weekend. You've been warned. Show up.
So